if we had started with word problems, it's very overwhelming. As you can tell, right? Word problems is it's a whole different animal, right? It's harder to deal with. So I wanted you to be really good at this so that when I started with the word problems, right, with the text, context, right, that is, you're focusing on that now. And that's what we're going to focus on today and tomorrow, and then slowly build, like complete the cycle where we're going to go word problem, come up with the inequalities, let's graph that, come up with the solution region. And there's one more step, but we do that at the very end, right? But for now, this is kind of like the chain that we're trying to follow, okay? The cycle. And yesterday, I only assigned a word problem with just one inequality in it. Yeah. So today, we're going to do 2 or more, okay? So here we go. I have a handout that I'm going to give you after, but for now, I'm just going to do this in your notes, okay? So here we go. A car manufacturer produces cars and vans. And for now, I'm going to give you a lot of items in bullet form. Okay. It takes 6 hours to make a car. And 7 hours to make a van. So I'm simplifying this, right? I'm not going too specific, but it's just, right? It takes 6 hours to make a car, 7 hours to make a van, right? The cost to produce a car and a van is $7,500 and $15,000 respectively, that is, right? So we're assuming 7,500 is for the car and the van is 15,000. Okay. And so these are just facts here. We're just going to state that, and here come the restrictions. And at first, I'm going to be very explicit, like this. These are the restrictions. Come up with inequalities. Later on, they might be hidden in the text. Okay. So here we go. Restrictions. The company needs to produce at least 9 vehicles. Okay. The maximum that can be spent is $225,000. This would be considered sometimes when you work through some of the questions I will assign. It's also a budget. So right, a company has a certain budget. This is how much it can spend. So it's kind of saying the same thing. And then there are 115 hours of production time available. I'm just going to do this here short. There are 15 hours time available. Due to the this is the last one. Due to demand, the company, this one is a tougher cookie here. The company makes twice as many or more vans compared to cars. Yikes, right? It's okay. I'm going to guide you through it. And when I do a course evaluation at the end of the semester, most students say, why do you always give us easy examples, and then when you assign, then it gets too tough, right? So I kind of think through the example, and I want to have enough in there that will guide you through almost any circumstance, right? Any example that is thrown at you, right? So here we go. Let's define our variables first of all. X and Y. By the way, sometimes you can use any letters you would like. If you want to use C for cars and V for vans, that's fine. I tend to stick with X and Y. Okay. So X would be, in this case, what? Cars, yeah. So number of cars, right? And Y would be the number of vans. Okay. We're going to throw in there that both variables will be positive. Okay. What kind of data are we talking about if it's cars and vans? It's discrete, right? So let's just make that note. It will come in handy later, okay? We just can't have decimal answers later when we graph this, right? So that's that. So this is the tough part, right? So we're gonna have inequalities, and if you look at these bullets, every one of these bullets represents one inequality. So we will have 4 inequalities when we're done with this. Okay, so let's do one at a time. Restriction, it says that the company needs to produce at least 9 vehicles. I'm going to highlight that part. If you see at least or at most or a minimum of, that is a restriction, right? And I'll give you a little hint here. Let's give you a little trick tip to get this right the first time. On the side here somewhere, on the right side here, if you see at least, minimum, at least minimum, you are expecting this inequality has to be greater than facing the right. You always read it from left to right. So this side is greater than that. If you see at most, up to, or max. Sorry, this is a side note. It's a bit small, right? But if you see at most, or you can have up to, there's a capacity of, then you want it the other way, like that. So this is just a little side note, because you've seen enough. You've seen me do quite a few of these, but now, right, it's nice to have that ready to go, so you're not mixing them up, because that would affect your graph. Let's go back here now to the first inequality. The company needs to produce at least 9 vehicles. So 9 vehicles, we're talking both combined, right? So we will write the number of cars and the number of vans has to be at least 9. So you go over here, at least, that means that the combination of cars and vans has to be greater than 9. Does that make sense? Right? whatever you make, doesn't matter, has to be more than 9. So you can make, 1 and 8, it could be exactly equal to 9, right? So you could make 1 car, 8 vans, 8 cars, 1 van, or more, okay? There you go. So that's a restriction on the amount of cars produced. Then next one is the maximum. There's that word maximum that can be spent is 225,000. So there's a restriction on the amount you can spend. That's when you go up and look like where are there's some dollar amounts that were mentioned. 7,500 that it costs to make a car, 15,000 to make a van. Those are the coefficients that you need to place in front of your variable. So 7,500 for a car plus 15,000 for a van. That amount spent can be no more than, right, 225,000. So dollar amount, right? And then we have the dollar amount coefficients in front of our variables, right? Next, there are 115 hours of production time available. So what does available mean? What could we replace that with? Maximum, right? You have that available. It's up to that, right? So you can say max. If you want to replace that with max, then you plug that in there. Okay? And so we're talking time. I'm going to go back up and scan, right? Like we're told how long it takes to produce each one. It happens, right? So it's 6 hours for every car. And if you spend 7 hours on every van, that has to be, right, less than or equal to 115 hours. Always watch out for time. Is it in minutes? Is it mixing up hours and minutes? In this case, everything is in hours. We're good to go. How are we doing so far? You're following? Yeah? Okay. Now the last one. This is what that's gonna, and I have these in the handout to practice. So this is the tricky one. Due to demand, the company makes twice as many or more. So it's basically saying at least twice as many vans compared to cars. Right? So it could have said they're making 4 times as many or 3 times as many. In this case, it's twice as many. Okay. So this is how you do it. You place your cars here and your van there. Okay. So we're comparing both of the variables, one to each other. Okay. And so where would you put the 2 in front? That is always which one do you want more of, by the way? You want more vans, right? So I can already tell you that this is going to go like this. You want more of the vans. Where would you put the 2 in front? In front of the Y? Because we're thinking 2 times as many vans, right? It's the opposite of that you need to do. You need to do the opposite. You need to put the 2 in front of the cars. And here is why. I'm going to take my piece of scrap paper because I don't want to have the notes too. So let's say this, right? If you make 1 car, right? If you make 1 car, we plug that in there. So 2 times 1, right? So you'd have 2 is greater than Y, right? So you're basically saying that if you make 1 car, then you would have to make 2 vans in this case. So the Y value is 2, right? If you had made 2 cars, let's plug in the 2 here. 2 times 2 It's less than or equal to 4, or y, sorry. So 2 times 2 is 4, right? So you're making, in this case, you would be making 4 vans. So the pattern continues. So if it's saying that you want to make twice as many vans compared to cars, that you have to put the 2 in front of the cars. If it had been the other way around, right, more cars than vans, then the 2 goes. So this will take some practice to wrap your head around, okay? But nonetheless, that's the inequality that you would have to use in that case. So I'm looking at my time here. Today, I don't want to really go into graphing just yet. The graphing part, I think we can handle. It's coming up with these that is crucial right now. Because if you get these wrong and then graph, it's going to be very frustrating. So I'm going to give you a handout, okay? Don't write after this. Leave room after this because we are going to graph this probably tomorrow. But I'm just going to give you a handout where you're going to practice writing these. And so I'm going to give you some class time to do that. And then after a while, I will go over at least one question to see if you're getting the same as me. And the rest will be homework, okay? So let me give you, right, we have, and this is not over today anyway, so we have pork sandwiches and hot dogs, right? The cost to the owner, so there is a cost to the owner is $1.25 for a sandwich and 50 cents for a hot dog. The owner profits $2.50. Profit means you make that, and $1.50 per hot dog. So here are the restrictions, and I leave some room there to write them right under, but it won't always be the case. Sometimes it'll just be a bunch, like a word problem, right? So here we go. So you have a budget of $7.50. I talked about that earlier. So you can, like, the cost that can be absorbed by the owner is, right, sorry, $1.25 for every sandwich, 50 cents for every hot dog. That has to be less than or equal to $7.50. Because a budget, right, it's basically saying you have up to or a maximum of $750 available. The food stand has enough supplies to serve 650 sandwiches. You can serve up to 650 sandwich and hot dogs combined, right? So this is not saying don't make up numbers. Okay, some students say, oh, maybe 300 hot dogs and 350. No, it's combined. So both of those combined, notice that my coefficient is 1 and 1, right? So it's basically just the variables combined can have to be less than or equal to 650, right? The owner would like to profit at least $1,000. So then you go up and you look at the coefficients here, 250 for every hot sandwich and 150 for every hot dog. You want this to be at least, to give you at least $1,000 because you want to make money, right? So that's that. Oh, some students think that if there are decimals here, that this is continuous data. But actually, if you think about it, and I haven't done that yet, I left it for the end, but what are these? What do these represent? X represents number of sandwiches, Y hot dogs. So can those be, some of you might say, yeah, you can get half a hot dog, but not really. You can't buy half a hot dog, right? So it is discrete. Always look back at your variables, not at the numbers that show up, all right? All right, the owner would like to sell, this one is tricky, sell at least twice as many sandwiches for every hot dog sold. Okay, so this is how I do it, one way of doing it. I put both variables like that. When you have, it could be 3 times as many, 4 times as many, 10 times as many. In this case, it's twice again, right? So which one do you want more to sell more of? Sandwiches. So we're gonna do this. That's half the battle right there. So which one will get the 2? Twice as many sandwiches for every hot dog. These are sandwiches and these are hot dogs, right? Sandwiches, hot dogs. Sandwiches, hot dogs, right? And so the 2 would go in front of the Y. Yes. Sorry, did I get that wrong? Sorry, the sign is wrong. The sign is wrong. You want more sandwiches. Sorry. See, even I can get that wrong. Even I. I don't make mistakes, right, guys? You can attest to that. There you go. Yes, sorry, I mixed it up. I want more sandwiches than hot dogs, right? And I want twice as many sandwiches sold compared to the hot dogs. So that's the correct inequality there. We're going to work that out later because to graph it, we don't want the 2 in front of the Y, correct? We're going to work that out later, no problem. So here we're going to let X be, I'm looking at my time here, we're good still, number of sandwiches. Y would be the number of hot dogs. Okay? At first, I'm going to guide you quite a bit, but then I'm slowly going to let go, right? The training wheels are going to come off, and then it's going to be just one paragraph, right? And you're going to have to go scan for keywords to see where are the restrictions here, where are the restrictions here, okay? So soon the training wheels are coming off. Let's do the last one here. This one, you notice that I do not have a restriction heading. Did you notice that? So one training wheel is off. You're just down to one side, right? Emily has 2 part-time jobs, working at Canadian Tire and Wendy's, right? Anybody working at Canadian Tire or Wendy's in here? No? Okay. You know why I'm asking? Because I always have a student at this Canadian Tire saying hi to me, and I'm like, do I recognize you? Do I remember you? And he's like, yeah, I'm so-and-so. It's like, oh yeah, that's right. Didn't recognize you with a mask. You know what? I will make this homework. Okay, I'm looking at my time. Homework, and watch this. Page 11 and 12 in the workbook. Can I say this? Don't graph just yet. Unless if you want to, go ahead, but don't graph just yet. And remember yesterday's handout where you go from the graph to the inequality? If you haven't done that, you do that as well, okay? Thank you, guys.